Assalamualaikum. Good day. Hi. This is the fourth part of topic 4 on the biocatalyst section. So in this presentation, we're going to look on the models for complex enzyme kinetics, okay, which involve the inhibitions of the enzyme reaction. Okay, you can refer to the textbook Schuler and Kargi in chapter 3 on enzymes. We start with the allosteric enzyme. What is allosteric enzymes? Why do we need to know on the allosteric enzymes? Because this type of enzymes, it involved in the inhibition study, okay, for the enzyme kinetics. Alright, so these allosteric enzymes, it possesses more than one substrate binding, so means that it have more than one site, okay, other than the active site. Okay, the binding of one substrate molecule to the enzymes, okay, which facilitates the binding of other substrates molecule. This is known as allostery or cooperative binding, which we often see in regulatory enzymes. Okay, allosteric. Allos means other, which is other side. Steros means shape. Okay, means that there is another shape of site on the enzymes other than the active site. Okay, so in order for us to know whether the reaction is being activated or inhibited, what we can do is we can plot a graph of ln V over Vm, okay, Vm minus V versus ln S, okay, where from the graph, okay, you can identify from the slope of the graph the cooperativity coefficient referring to n, because from the n value, if the n is higher than 1, then it indicates that it is a positive cooperativity, which is activator. If the n is lower than 1, then it is an inhibitor. Okay, so this graph is being come up from the linear line equation, okay, from the equation 3.19. Okay, so from the Michaelis-Menten plot, we can see the hyperbolic pattern. But if there is a allosteric, okay, for allosteric enzyme, the pattern will be in this way. Okay. Alright, on the enzyme inhibition, there are 3 types of enzyme inhibitions. But before we go through one by one, let us see. Okay, what is inhibitor? Inhibitors, same like chemical reaction, it's a compound which decreases the enzyme activity or the reaction activity of the reaction. So we have an irreversible inhibitors, and we also have reversible inhibitor. Okay, so this irreversible inhibitor and reversible inhibitor, it is different from the irreversible reaction and reversible reaction. Okay, this is irreversible for the inhibitor. Okay, not for the reaction, for the inhibitor. We are referring to the inhibitor. Okay, so irreversible inhibitor, which is known as inactivators, it reacts with enzyme, okay, in which one inhibitor molecule can permanently shut off one enzyme molecule, and they are often a powerful toxin, but also may use as a drug. For reversible, okay, reversible inhibitor bind to and can dissociate from the enzyme. It bind and then it can dissociate, okay, from the enzyme. Okay, then they often a structural analogs of enzyme or products and being used as a drug to slow down a specific enzyme. So this type of enzyme, reversible inhibitor, this type of reversible inhibitor is always being used in the inhibition reaction or study. So the reversible inhibitor, it can bind to the free enzyme and prevent the binding of other substrate, and it can bind to the enzyme substrate complex and prevent the reaction. Okay, it can be either one or both, right? Okay, we start with the first inhibition type or mode. The first mode of inhibition is known as competitive. So this competitive inhibition, it involves direct competition between the inhibitor and substrate on the free enzyme. You can see from the equation mechanism here. Okay, the inhibitor, okay, compete with the substrate in order to get the site on the enzyme. Okay, so inhibitor, it binds to the same site on which the substrate will bind. Okay, so in simple word, means that inhibitor will push away the substrate, so it cannot bind, so the inhibitor will bind to the site. Okay, so often the structure of the inhibitor and substrate is similar, because we know that the active site, it has a specific shape, so only the specific substrate or inhibitor can attach to the site. Okay, and this type of inhibition is the most common type of enzyme inhibition. And you can see here, there is a Ki value there, Ki. Okay, so Ki is the inhibitor constant that indicates how potent of an inhibitor, and it is the concentration required to produce half maximum inhibition. So for the inhibition study, it's not only we calculate the Km and Vm value and Kcat value, but we need to calculate the Ki value also. Okay, there is an addition of constant there, Ki for inhibition. So for the normal enzymatic reaction, okay, the kinetic parameters that being calculated are Vm, Km and Kcat. But for the inhibition, okay, of the enzymatic study, there is an additional of one constant, which is the Ki. Okay. Alright, so this slide shows, okay, the linear equation of Line-Weaver-Burke for inhibition. Okay, so you can see there there is an inclusion of Ki in the equation, okay, in compared to the linear Line-Weaver-Burke equation before. Okay, so this linear line equation is referring to the normal standard linear line equation, which is y equals to mx plus b or plus c. Okay.